The next protocol is called as Ethernet. Ethernet was actually one of the famous protocols used in LAN. Almost all the other protocols are lost to nowadays, but the Ethernet is still exists due to its updated version. On day by day, it's regularly updating itself, so Ethernet is still available in the market. Ethernet was actually developed during 1972 by a company called as Xerox Palo Alto Research Center. In short, we are called it as PARC. The Ethernet actually, the data transmission rate or speed ranges from 10 Mbps to 1000 Mbps. Initially, it is showing 10 Mbps as the data transmission rate. It is upgraded up to 1000 Mbps. That is called gigabit Ethernet. Now, actually, the Ethernet uses a technique called as CSMA-CD, that is Carrier Sense Multiple Access Collision Detection Technique for a media access. So, it is using one persistent technique for media access. At the beginning stage, when the Ethernet is developed, it is supporting only half duplex communication. You know what is the meaning of half duplex communication? That means a device can send or receive a data without simultaneously. That means only one device can send the data and other device can just receive the data. Both sending and receiving cannot be done by the same station at a time. So that is called as half duplex communication. Due to this half duplex communication, the data transfer rate is very slow. If the number of nodes increases, the data transmission of the Ethernet goes on decreases. One more problem with this one is the probability of collision is also increases. Whenever more number of nodes are there, the collision also more. The first Ethernet is actually developed using 10 base 5 cables. That means coaxial cables like this way. To overcome such problems, instead of half duplex, it is converted into full duplex communication. In full duplex communications, more than one node can transmit as well as receive simultaneously. That is, receiving and sending the data simultaneously possible. It is not using a CSMA-CD technology. The full duplex communication won't use any CSMA-CD technology for media access. It is achieving this full duplex by using a special device called a switch. Okay, it is using a device called a switch that can transmit data based on the destination address. Switch can transmit the data based on the destination address. So full duplex is possible here. With the switch, it is using a UTP cables, a pair of UTP cables. Two pairs are used for transmitting the data and two pairs are used for receiving the data. So there is a separate cable for transmit and separate cable for receiving the data, the UTP, which is connected to switch. So there is no any data loss or data collision because separate lines are used for transmit as well as receive. So full duplex communication is possible here. As we are using a separate cable for data transmission as well as receiving, the data transmission speed is also increased to 20 Mbps. Instead of 10 Mbps, it becomes 20 Mbps. Now this is the diagram shows the full duplex mode. We are using one switch here. Okay, it's called the 10 base T cable here. It's a switch and it is connected like this way. A separate pair of cables are there. And today we are using UTP cables for the Ethernet or optical cables. Now we will study here how actually the data transmission occurs. Now assume that a node A and node C want to transmit the data at the same time. So what actually they will do, they just sense this media for any idle state. Means nobody is using this channel or line for data transmission is censored by both A and C. They found that this line is idle. So they will transmit the data simultaneously. Both node will send the data simultaneously. As the data frame progress here, like this way and this way, here at the station B, collision occurs. Nearer to this node B, a collision occurs. And this is identified by a node B immediately. And it will send one signal to all the nodes. It will send a signal to all the nodes in the network and inform that a collision occurs. So all the other nodes are just stop its transmission. A and C will stop its transmission and waited for some random period of time before transmitting the new frame. Like that, the Ethernet data transmission occurs. Now, some of the advantages of Ethernet. The first advantage of Ethernet is it supports various kinds of media such as coaxial cable, twisted pair cable, optical fiber cables, etc. Means we have a flexibility in selecting the various types of media. It also supports bus as well as star topology. The cost of the Ethernet is less compared to your ARCnet, token ring as well as FDDI LANs. Fast Ethernet and Gigabit Ethernet offers network administrators a flexibility to select a speed. Whenever you need the speed LAN, you can jump to a Gigabit Ethernet as well as Fast Ethernet. Wherever a data transmission is not continuous, means the stations are not sending the data and continuously. Okay, at sometimes it will transmit, at sometimes it will wait for the like that one. In that case situation, CSMA CD method for media access is suitable for this situation. Okay, when the data transfer is less, the Ethernet is the best choice. The next one is called as the disadvantage of Ethernet. It is impossible to predict exact period of time a node needs to wait before it can start transmitting the data. So wherever the node has to wait for the data transmission, in that situation we are not using Ethernet. One more disadvantage of this one is in Ethernet most of the times we are using hub as a device, due to which broadcasting will be occurs. A broadcast data across the network resulting in an increase of network traffic. the network traffic is more in the Ethernet. To overcome that problems, we are generally dividing the network into multiple broadcast domain. Means instead of a single Ethernet, we are divided into multiple Ethernet segments. Or one more technique is we are using a switch instead of hub. We are using a device called a switch to interconnect different nodes.